get started. I'm Dave Martinson from the American Chemical Society and current chair of the Communications and Publications Committee of the Chemical Information Division. And I'd like to welcome you all to this webinar, the fifth in our series of webinars. And one of the goals of the series was to make some of the sessions that we put on at the ACS meetings available to a larger number of our members, many of whom are not able to attend national meetings, and also for those that are that can't attend every session because of the parallel sessions. We've also had some speakers who don't normally make it to the ACS meetings, so we've extended the programming that the programming committee is able to put on. We appreciate any feedback you'd have about the series. If you send to chair@acsinf.org. Tony Williams is the current chair. So today we're happy to have Martin Walker with us from SUNY Potsdam. He's been involved in the chemistry section of Wikipedia for a number of years, and he's going to share some of his experiences as a chemical information Wikipedian. 81 from Bristol, University of Bristol, then worked for a number of years before going back and getting his PhD from Brandeis University in 1998. He's been on the faculty of SUNY Potsdam since 2001 and has been a long-standing interest in chemical information and more recently working on Wikipedia and a couple other interesting things while on sabbatical. He became involved with the Learn Chemistry Wiki, and he's been involved in some local events for ACS in the Potsdam area. So with that, Martin, I will turn this over to you.
Martin Walker from SUNY Potsdam, and I'm here today to talk about using Wikipedia as a source of chemical information. And this is a summary of the talk I'm giving. We have a general introduction, and then I'll go through specifically chemical substance data. We'll look at other kinds of things like reactions and chemical biographies, things like that that are of interest to chemists. Then I'd like to take you behind the scenes a bit to show you really how articles are written, because I know for many people outside the Wikipedia community, this is a bit of a mystery, and I'll show you how things are both written and also maintained to make sure there isn't vandalism and how things are structured. Okay, and then we'll conclude, and I'll take a few questions at the end. So first of all, a quick run through what a wiki actually is. Wikis are more than just Wikipedia. It's actually means quick in Hawaiian. It takes its name in our case from the Wiki bus, which takes people to the airport in Hawaii, and it was just a cool name that was devised for any collaborative website that can be directly edited by anyone who can access it. So anybody, as long as they're not blocked or banned or something, can edit, say, Wikipedia, even anonymously. You can limit to account holders only if you want, but basically, rather than having just a specific person writing a website, you have now the whole of the readership writing as well as reading. And Wikipedia, which most of you will use, I'm sure, is based on this, and it's a multilingual encyclopedia project using this type of approach, and it's non-profit. It's not a commercial thing, despite being one of the top 10 sites in the world. Its only goal is to bring free knowledge to the world. There are a lot of misconceptions about what Wikipedia is and does. It is an encyclopedia. People try to stretch that to say, I have all these opinions, and I want all these millions of people to read them. That's not appropriate. You have to be careful, like any encyclopedia, in citing it, that you cite it carefully and realize it's not as authoritative as a primary source. It is written by volunteers, but my experience in chemistry is most of those volunteers are either PhD chemists or practicing chemists or extremely smart chemistry students. And it's not a bunch of science geek kids who are 13 years old or something. But anyone can actually edit, and so those kids do get in now and again. But overall, the majority of the content that you will read is actually written by professional chemists or pretty serious students of chemistry. You can freely use it, and you can even use it for commercial use if you want, as long as you attribute your source as Wikipedia. But it's not trying to make money. Your traditional approach to encyclopedias is something like, it's based on an expert, and the nice thing is you have an authoritative resource as a result. The expert is very knowledgeable, probably picked for being very knowledgeable, but they may also have their own slant on things and their own opinions. Hopefully editors can deal with that. Wikipedia is very, very different, and it's based on the idea not of having one single expert, but of having many eyes looking at it. And the idea eventually is that it evolves into an article which is pretty sound and pretty knowledgeable. In fact, of course, people, when they volunteer to write things, usually write in areas in which they're quite knowledgeable. There's a continual process of people adding stuff and then other people reviewing it and refining it, changing it, and so on. One thing that I think is special about Wikipedia, which compared to many web resources, is that you actually have human beings continually adding content in. And that makes it different from most chemical information sources on the web, which involve a lot of machine-generated information. That's not to say there's nothing in Wikipedia which is generated by a machine. They obviously try and automate routine tasks, but in many cases you will find information on Wikipedia that you will not find elsewhere, and it's because some guy in Australia knows a bit about that subject and has a useful paper on it and added it in. And it may not be in any of the standard web sources, but the expert guy has added it in. But of course the downside is humans make mistakes as well, and so we get the silly mistakes. One good thing is also that I don't have listed on here is that in fact when mistakes are found, they're very often fixed very quickly, because a human being can deal with that a lot faster than a machine, in fact, as long as it's a specific mistake. So let's look at a typical Wikipedia article, and this is the kind of thing you'll see, and we'll talk about these sorts of articles in more detail later. But generally speaking, it's describing a specific topic. Now, I realize that may be kind of obvious, but many people misunderstand actually what the concept involves. It is just an encyclopedia article on the main page. But also look up here at these tabs, which many people seem to miss. The discussion tab. If you disagree with something in the article, you don't edit the article and say this is a load of garbage. You actually put comment on the discussion page. You click on the discussion tab and then write this article is a load of garbage. preferably saying which particular things you think are poor. There's also a history tab. That allows you to look at every single earlier version of the article, going right back to when the article was written. And in the case of methanol, that might be 2001. So you can really see how the article's evolved. And you can obviously do the edit tab to change things. Since I did the screenshot, in fact, just in the last few weeks, they've begun to test out a new edit tab. They have edit and edit source. The edit tab allows you more like a WYSIWYG type edit. And there's also edit source, which is the more traditional, where you have to know these various codes for wiki codes. So they've actually been trying to make it a lot easier to edit things. So now if you just want to change the spelling of a word that's misspelled, you can just click on edit, and it's just like typing in Microsoft Word or something like that. Okay, chemical substance information in particular. Here is sodium sulfate, one of my favorite ones. You see a lead part at the beginning, you see a chem box on the right, and you see these types of topics down the side. And this sort of content is very typical. You can see physical and chemical properties. Most substantial articles will have those in. You've also got how to make it and how to use it. In many cases, if it's a reagent, you know, the reactions it does. In the case of sodium sulfate, it's more like industrial applications. The chem box contains both the identifiers like CAS registry numbers, ChemSpider IDs, things like that, but also boiling point, melting point, solubility, and so on. And what we don't do here is cover safety in detail. We do include specific EU numbers, R and S numbers, and things like that, but we don't include a full safety data sheet. And that was a deliberate decision early on, because we felt if we weren't careful, we'd become like a list of MSDSs, which is not what we're trying to do here. Also, chemical suppliers, we used to have them in, but it became, well, why is our company not in and their company is, and so on, and it was easier just not to have to deal with that side of things. So, substance data. One thing is, as cheminformaticians, you're used to thinking in terms of databases for substance data, but Wikipedia is structured differently. And I've even seen edits reverted in Wikipedia with the comment, Wikipedia is not a database. So many people, however, want to use it like a database because it is a huge resource of data, but it's not structured in your traditional way. Now, there are a couple of things. DBpedia is trying to, that's a German project to try and make, it tries to pull out all of the data from Wikipedia into a database and make it searchable using database type terms. And there's also, in fact, a multilingual project called Wikidata, which is trying to help different Wikipedias and different projects of the Wikimedia Foundation share data between, so the melting point of sodium sulfate, for instance, is the same whether you're Japanese or Turkish or English, and so they could use the data, they could share the data between Wikipedias. The Chembox and Drugbox are obviously the main place you will get data, and I've already said the kinds of things you have in here. In the early days, people would simply perhaps look up an INCHI and copy and paste, but we've tried to, for searching with machines and so on, we've tried to structure it though. We were approached by various database groups and asked, could we structure it to make it more useful for cheminformatics groups? This was academics. So we tried to help. As chemists, we want to make sure that the chemistry community is helped as much as possible. This is what an old-fashioned ChemBox was like. This is the design I was involved with. And I'll get to this in a minute. One of the problems is some of the identifiers, like INCHIs, if you put them in full, palytoxin is a huge molecule, so its INCHI is huge. How do you deal with that? In the traditional ChemBox, that became very difficult. So we just didn't have it in at all. The solution came when we switched to the new ChemBox, which some people a lot smarter than me designed to be able to be more machine readable. And in effect, it's got some characteristics of a database behind it. A lot of the information is read in as fields, and these fields are also linked often to the relevant databases automatically. And the hide show thing, which is this thing to the right, allows us to hide the INCHI, which most people don't want to read the INCHI when they're reading the article. But if you want to see that, you can just click on that and see it. So, and we've been able to then put collections together of ChemBox data and share those with the cheminformatics community. And if you need that, please, by all means, email me or something. So this is how the ChemBox works. We have, for most people just starting an article, they don't want to be overwhelmed with 500 different fields, most of which will be irrelevant or unimportant for the topic they're considering. So we have a simple ChemBox which says, I have this organic compound and I just want to put things like the melting point and its formula, its CAS number, and an image file which has the structure. So the simple ChemBox is what most people will use to start with. If there are specific data fields that are important to add, then you can take these from the full form and insert those into the article. So the INCHI and INCHI key, I want to put a little bit of a plug in for these. These are a useful identifier that we use, as well as the CAS registry number. The CAS registry number is substance-based, which is really useful at the macroscopic level. But if I draw a structure in ChemDraw, I can't just generate a CAS registry number on the fly. And so the INCHI is a useful thing that you can do that with. So you can actually search. You can also generate an INCHI key, which is a web searchable version of that. And so we inserted these into many Wikipedia articles. It's probably not 100% of the substances yet, but we have a lot of them in. We also have a lot of data which are not on the main article page. And there's a reason for this. In the early days, people would just keep adding and adding and adding extra lines into the table. And my attempt at a joke here, the standard free energy of hydroformylation in a black box. We would get these things that I had no clue what you would use this information for, but it was some someone wanted this thermodynamic information inserted into the main article on benzene or something. And so before long, your ChemBox would have 500 fields in it, and would be 10 times longer than the article. So how could we put this information into Wikipedia without it messing up the article? Because someone somewhere may find that useful. And in some cases, things like NMR spectra are quite popular for people to look at, but it's not necessarily appropriate in a general purpose encyclopedia to have NMR data and IR data for every chemical substance. So we created these supplementary data pages, and you can just click on a link from the ChemBox, which is near the bottom of the ChemBox. And if you click on that, it takes you to a page that has a ton of information. And I've just shown, this is a table of contents from a typical one. And you can see we put in a lot of thermodynamic data in there. Someone actually went through and did, for several organic compounds, they did these, plotted these nice graphs for us of vapor pressure versus temperature, which I think are beautiful. The kind of information a chemist, practicing chemist, may look for in Wikipedia and get frustrated that they can't find. So look on the supplementary data page, and you may find what you're looking for. They are a bit spotty because they're not as high profile. Some of those data pages are pretty bare. But in that case, if you have the data, please add them in, and you'll contribute to Wikipedia. The drug pages, they're kind of structured in a similar way, except in this case, the emphasis is on the medical aspects. Now, we've worked with the drug people and said, what chemical fields should be included. And so, some of the main databases, CAS, ChemSpider, PubChem, and so on, are included here. So you'll see a lot of the same information, but you also have, Medline Plus is more important for a drug, the legal status, and so on. And very often you'll find dose levels and things like this. They're maintained by the Pharmacology Project, and so obviously their focus is different, and they don't have the supplementary data pages. I should mention those supplementary data pages, you won't find them in history or philosophy or psychology or even physics, as far as I know. It's a unique thing to chemistry. And if the hardcore admins at the top find out what we're doing, they might get mad at us because it's a little unorthodox, but we've had them for about 10 years now, and so I think we can make a case to keep them. But you won't find those data pages for drug boxes. One problem we have is a sort of collision, because what if a drug is also a common chemical reagent as well? Things like DMSO it's used with horses, but it's also used as a polar aprotic solvent. And I've given an example here. If you look, caffeine has a drug box. It's treated as a drug, and yet paraxanthine, which is just different by losing a methyl group, is treated as a chemical. So the data fields you'll see on those articles are different. And I don't know a simple way around that without upsetting a lot of people in pharmacology and chemistry. So, okay, what about other chemistry content? And I come from a background of a big interest in chemical reactions, and so this is very dear to my heart. And here's a typical reaction article. Now, one of the first things you see is obviously a generic description of the reaction, like you might see in Jerry March or something. The other thing you may notice is the lack of any kind of chem box on the right-hand side. Those do occur in just a handful of articles, and this is one of them. But generally speaking, those reaction boxes, as they're called, are pretty rare. And I think part of the reason for this is a chemical substance is very easy to define. You can draw a structure for it if it's a pure substance, usually at least. And it has a fairly precise definition in most cases. Reactions are much harder to pin down. Defining the scope and limitations of a reaction can be very hard, and I doubt if you got 10 chemists in a room, if they could even agree necessarily on a precise definition for even some common chemical reactions. The easy ones tend to be the name reactions, which are more clearly defined. But defining how you generically oxidize an aldehyde to a carboxylic acid is a bit harder. So reaction articles in general, I've already mentioned, coverage can be patchy for sort of general reactions that are not name reactions. The reaction boxes are pretty rare, but you will see in nearly all reaction articles that are more than simple short paragraphs, short stubs as we call them. You will see usually a mechanism, and this is beyond the lead section, by the way, which I've already described. You will see mechanism, the common reagents, and so on. The scope and limitations is in some articles, not all, likewise stereochemistry. And then there are variations. If it's the, for instance, the Evans oxazolidinone modification of the aldol reaction, for instance, and the Crimmins modification, you'll see those in the aldol article because these are common variations. Another type of article that's dear to my heart, in fact I took this picture of Noyori myself, though I didn't write this article, but I like biographical articles. I think it's important that we inspire our students. We have enough articles on pop stars and let's say porn stars as well, is a sore point, I know. We have lots of articles on celebrities. Why don't we have more on chemists? We have some very eminent chemists who have no articles on them. But enough of my soapbox. This is how a typical article is structured. There is a box for biographical articles because a large proportion of Wikipedia is in fact biographical articles. I forget the proportion, but something like a third. It's a huge proportion anyway. And so there's a standard structure for these. We typically focus on their professional work, and in this case also a description of Noyori's research. You may also see a personal life section, when he got married and so on, things like that. But mostly the interest is in the professional side. We do have a lot of Nobel laureates and important people like Lewis, and then there are a few where perhaps someone had someone as a PhD advisor and knows a bit about them and has taken the time to put together an article. In my case, I've written them mainly based on the fact that I was able to get a good picture of someone at a conference, and they're an eminent chemist, so let me add a bit about them. One problem is we don't want vanity articles. I'm Dr. Nobody from Nowhere University, and I'm up for tenure soon, so I'm going to write an article on Wikipedia about how wonderful I am. Obviously, we try to prevent that. And by the way, those sorts of vanity articles even occur in other general chemistry articles, people trying to add citations of their own work and so on. So we have to be pretty careful about what gets added in. I could talk all day about all the different chemistry articles, but I don't want to bore you totally. So these are all or many of the different types of articles that you can have. Obviously, you would look up hard soft acid base theory, or you might look up an article on the Boltzmann constant, various things like that. Chemical companies are a fun one. They sometimes get hijacked by the company or hijacked by the environmentalists who hate the company. But all sorts of things, as you know, pretty useful. Functional groups, the article's sometimes pretty good. We do have functional group articles for pretty much every functional group that's out there, but they're not necessarily all good. Some are. So how do articles get written? Well, it's down to people like this guy, Polymeric. You can guess from his username what his research is. He works in Łódź in Poland, and actually he contributes to the Polish Wikipedia. So someone like him will, Polymeric, will sit down at a computer and say, we really need an article on this, or we really need to expand this article. These people, if they're not trying to push their own article or push their own pet theory or something like that, and that's usually pretty obvious by the person's edits, if they're genuinely trying to contribute to the body of knowledge available for free on the internet, it will become apparent through their edits that really they're simply scholars who love learning and they want to share that. That's not uncommon amongst academics and indeed many industrial chemists too. They know a lot about a specific subject, and their wife is sick of hearing about it, or their husband, and they would love to share that with someone who's interested. And the nice thing today is that when you do that, you actually get read by many, many people. These editors then get together into wiki projects. And these were started pretty early on by groups of like-minded editors working in a common area. And the idea was that in the case of chemistry and chemicals, we could decide how to lay out the articles and what should go in, what shouldn't, and also keep an eye on the articles that are of interest to us and make sure. And if we disagree, we can figure out what the best way is, come to a consensus. These wiki projects have fairly lively talk pages, some more lively than others, and a lot of the purpose of these pages is simply to say, hey, I'm doing this, or someone's doing that, keep an eye on this, and so on. So I'm asking for your comments on what I've done here, etc. But sometimes, and this one is actually taken from the Wiki Project Elements talk page, a discussion about what polonium is. And some of these discussions may seem a bit arcane or pedantic, but in fact, you have to realize, I think I looked up this polonium article, and it's hundreds of thousands of hits a year. So really, if Wikipedia says polonium is not a metalloid, or polonium is a metalloid, that actually has a profound influence on what even eminent academics will write in their textbooks. And that consensus is decided by people called Double Sharp, Runtgenium, and so on, discussing it like this. Now, okay, it is by a small group of people, but these are people who care passionately about whether polonium is a metalloid or not. And the other thing is, this is a public debate, and if you disagree violently with what they're saying, you can go in and add your comment, even as a non-member of the Wiki project. There are also, probably a similar discussion is happening on the talk page of the polonium article itself, which would be the normal place the public would comment. Now, what type of, what Wiki project is involved depends on the type of article that you're considering. Chemistry is a catch-all for all sorts of things. Those biographical articles I mentioned, and in fact chemical reactions, fit in those that general area. Industrial processes and the general concepts, they will all fall under the catch-all Wiki project chemistry. Obviously, the elements Wiki project looks after chemical elements. They only have quite a narrow number of articles, but those articles are pretty high profile. Many get millions of hits a year, so they do very important work on those. Chemicals looks after chemical substances. They have more like 10,000 to 12,000, something like that, that they look after, and they're the ones who do the chem boxes. Now, obviously, you will see many people are members of several of these projects and are active in several of them. I've been active in both chemicals and chemistry. I haven't really contributed much to the elements articles, but they probably know who I am. So these are the people who are active. So if you're doing a major project to do with a certain type of article, you should talk to the relevant Wiki project. Now, one Wiki project which I forgot to add into this slide because they were inactive for a while, but they are in fact active now, is the Wiki project on polymers. And in fact, I've been doing a collaboration with some of the people who are interested in definitions of terms in polymer chemistry. And so we've been working with the Wiki project polymers to make sure they're aware of what we're doing. And so if you're doing any kind of major work, so if you have a class of students and you have that class editing a bunch of chemical substance articles, and before you start the project, talk to the Wiki project and make sure that they know what you're doing. And your life will be much easier, believe me. They can warn you of the pitfalls, guide you through the copyright issues and things like that, which are usually the kinds of, these are the kind of problems that bog down classes and can sometimes involve a lot of acrimony if things are handled badly. So, chemicals, it does have, I think, about 60 members, but really there are only perhaps 10 or 20 who are on every day editing, checking articles, and so on. They are constantly trying to improve the data boxes, as well as the routine patrols. They're trying to maintain those data boxes and expand them. What data fields should we be adding, and things like that. Making sure the naming is in line with current policies, etc. Article assessment is something that all Wiki projects do pretty much, and this is where the Wiki project member reads through the article and assesses how complete the article is and how good quality it is. And then there's a tag put on the talk page that says the Wiki project Chemicals assesses this article as B class. And then that article is listed. You can actually get whole lists of all of the Wiki project Chemicals articles, and you can see them ranked by class. Is it all the B class articles? And many also rank by importance as well. So you can find all the top importance articles for polymer chemistry or something like that. We've also done data validation, which again is it's actually something that where chemistry has kind of led the way in some ways, because we tried to ask ourselves, how can a reader be sure that what they're reading is correct? And on most of Wikipedia, actually, you can't do that. In chemistry, you can, to some extent, do that. So let me explain, first of all, how that... this is setting the standards. We have a whole manual of style. So if you are adding things like structures, names of, if it's a substance, how are you going to name your article? These are how to do the spellings and all the rest of it. So if you type in WP:/MOSChem, Manual of Style Chemistry, into the Wikipedia search box, it will take you to the general page, and it's got a bunch of subpages. So, or you can just Google that, and that will tell you all the settings for ChemDraw, etc. This is what the quality and importance things look like, and this is a table summarizing all the chemicals articles. You can see there are over 10,000 that have been tagged. There are probably a few that haven't been tagged yet. And this is what the article system is based on. I hope you can read this. The text is a bit small, but there's actually a lot more detailed guidelines if you're really going to do a bunch of assessments. So at the top you have featured articles, at the bottom you have stubs, and there's a sort of rainbow of colors going from red to blue as you go from very basic description to very good description. I love this periodic table. I'm not sure how current this is, but they've actually used those colors to create a table, and this shows the assessment of every element article of the first 118 elements in the periodic table. So the Elements Wiki project uses this to prioritize anything in red or orange. Was a priority early on. Now they're beginning to do the yellows, maybe even a few of the blues. Sorry, a few of the greens. Something else which I need to slip in somewhere, I'd like to get a plug in, no pun intended, for this add-on or plugin for Firefox called WikiTrust. I know many of you are librarians and things like that, and you're interested in, is this information correct? If you download this plugin, add-in, whatever it's called, for Firefox, you get an extra tab at the top. And if you click on that, it shows you the article colored according to how reliable the content is. And someone has actually taken every edit of every article in all the major languages of Wikipedia and looked at whether those edits were then reverted. And they've looked at the track record of every person who's ever edited Wikipedia and put those things together and come up with a trust metric that says this editor, a lot of their edits get changed or removed shortly afterwards. This editor, on the other hand, is very trustworthy because their edits are almost never removed. And then it takes that information, puts it back into the article again, and colors the article. So you can see Dow Chemical, I mentioned the chemical companies are often a bit controversial. This editor, who inserted this section on the Bhopal disaster, which was really Union Carbide, which was in fact bought by Dow Chemical years later, that was inserted by someone not very trustworthy. I may say Dow Chemical has been caught editing this article as well, and so as highlighted in the New York Times, much to their embarrassment. So you can, if you really want to look at how reliable the content is, stuff that's not got any color in the background is going to be pretty reliable. If it's got orange, I wouldn't trust that content at all. The community fights vandalism with a whole bunch of tools here. The watch list lists all the articles that I keep an eye on here. Huggle is a software tool that really speeds it up. The vandalism fighters can revert maybe 50 sets of vandalism in just 5 minutes or less. And then you have bots patrolling permanently that if you do any obvious vandalism, insert bad words into articles a lot, etc., it'll get deleted immediately. Collaborations, which I think Tony Williams was pointing out earlier. These wiki projects work to improve the content, often by working with other groups. And there are three main groups that the chemists have collaborated with. One is ChemSpider, and Tony Williams is with us today. And in fact, he really started off this idea of checking the data within Wikipedia, and we've worked with the ChemSpider people, not just to check data against ChemSpider alone, but against a lot of original sources, etc. And that was quite a major undertaking a few years ago. We haven't done so much lately, but we should probably get back to expanding that further. Also, a few years ago, we set up a collaboration with CAS, which kind of sprang out of the ChemSpider one. We wanted to check registry numbers, but we didn't want to break copyright. And CAS, when we approached them, released a database of around 8,000 chemicals to us with structures and CAS registry numbers, etc. So that was very helpful because we consider CAS to be a very reliable standard for chemical information, and so being able to compare our structures against a CAS structure was very useful. It also served as the basis of the CAS Commons Chemistry website, which is set up kind of as a result of putting this collection together. And that website is open to the general public. And it contains links to all the corresponding Wikipedia articles where there are corresponding articles. We've also had a UPAC collaboration. And in fact, I've been getting emails this last week. I've been doing edits within Wikipedia just in the last week on this topic. This UPAC definition was just added in a couple of days ago by, in fact, by a student in England, and the UPAC polymer group is working with us to carefully, tactfully add the polymer content into Wikipedia to make sure some of the definitions we have are a bit outdated, they've been revised, sometimes they're a bit misleading, and sometimes they're just plain wrong. So they're pointing out where we need to fix things, and I'm helping to make sure that process goes smoothly.
So let me ask right now if there's any questions from the audience. If you could type them into the chat box, we'll send them on to Martin, discuss them here. And if we have any time left at the end, we can talk about data validation. But
You will have
Here's,
to repeat,
don't
repeat
close everything down yet.
the question to me.
Don't close everything down yet. I will relay the question, but if you need your slides, we'll go back to them. So here's a question from Yi. I sometimes support our faculty members using Wikipedia editing as teaching tools in our university. Is ChemProject willing to collaborate with these instructors and librarians in identifying articles to work on and evaluating students' articles and so on?
I would say yes, but you need to work with the Wiki project. Sometimes student groups come in and make a lot of edits, sometimes to major articles, and things like the formatting of the article gets badly messed up, and that creates a lot of bad feeling. Sometimes a lot of copyrighted images or simply copy and paste from another website is inserted in because our students don't always understand copyright very well. So we need to have a very strong faculty moderator. And if you work with the appropriate Wiki project when you do this and say, on this day we will be doing edits on these articles, the Wikipedians will work with you and help deal with the mistakes that are made. One of my colleagues has done quite a bit of work with the geology wiki project. He's a geology professor, and that went very smoothly, but he found in his case it was best to set up a separate server on the campus where the students could edit away, and then they would upload the edits after they'd fixed all the mistakes. So what works for you depends, but by all means contact me if you want to do that. I can certainly help you or other faculty in doing that.
Okay, Yi says the librarian is involved for critical evaluation of resources and copyright clearance. So Martin, they should email you directly to initiate that collaboration. Okay.
Yeah.
Other questions? Okay, I don't see anyone typing in, but I have one myself. Do you have a feel for, in an ongoing sense, what the trends are in terms of the chemistry and chemical substances sites on Wikipedia? Has there been like an initial flurry of activity and then kind of a steady state since then? Are entries increasing? Are edits to existing entries ongoing?
I think things
Can you comment
are
on that?
quieter now than they were even 3 or 4 years ago. And some of the old-time editors are less active. I've been less active than I used to be in day-to-day edits. So in the early days, it was very exciting and a lot of people jumped in. And now in 2013, Wikipedia is a bit old-fashioned and it's not the trendy thing anymore. So there are fewer people, but there's nevertheless a hardcore of people and a steady trickle of new people coming in, and slowly new articles are being added. People are still using Wikipedia as an information resource, so you still get that instant big response. If you write a new article, you'll see thousands of hits on that page. So that still brings in new contributors, but it's not as lively as it used to be in any of the Wiki projects that I have worked with. Does that answer your question?
Yes, it does. Thanks. Any other questions from the audience? Maybe I'll ask another question that I have then. You talked about the safety information and the decision to keep away from that. And
Yeah.
so does that mean you went back and edited out safety information that had been included at one point? And is
Um,
that safety information still there if you look at the history, or did you somehow remove it completely?
okay, what we've usually done is add a link to a safety data sheet from one of the standard sources. And that way, if the information gets updated or something, we don't need to worry about being out of date. With certain pages, there is toxicological information included. But it would only be actually removed if you started putting in a huge section of safety information, making it read like a safety data sheet.
Okay. Well, we do have a comment, an interest in data validation. So why don't you spend the last 5 minutes going through that section of your slides?
Okay. I will try and get through this quickly, though. Okay. When I mean validation, I'm really trying to prove that the data are correct. Curation is just an ongoing process of fixing errors. So we've done a lot of validation efforts with CAS and with ChemSpider and Tony Williams in particular. We've built up mainly the identifier fields within the ChemBox now have these check marks, and this is where someone has gone through a list from, in this case, CAS, you can see, and checked that the substance matches with what's in the database, and if it does, it gets a green check mark. You may wonder how you can actually do this, but if you look in the history of an article, you can see that there are multiple versions of an article, and so if you pick the particular version which has the correct information in it, you can call that a validated version. And a bot, in fact, checks the ChemBox against that particular version. And you can see ChemoBot in there patrolling regularly to check that. Obviously, with the encyclopedia, anyone can edit. Some things may change, but something like the boiling point of water, we hope won't change. So we don't want people going in and ha ha ha, isn't it funny to change the boiling point of water in the water article. So this bot is trying to patrol, and anything that messes up a validated number is caught by ChemoBot and then flagged with a red X mark like that. You can see a cast number should not end with 3 numbers, and it took 11 minutes for ChemoBot to spot that. This is where the things are listed. You can see the version number of every validated article. Structures are a little trickier because they're held remotely on a separate server, the Wikimedia Commons server. And so we did set up a similar system though, but we've only done a few hundred substances here. The drug boxes are also checked and have the same identifiers checked. So I'll come to a conclusion. I'll just let you look at these shortcuts afterwards. These are just shortcuts you can type into the Wikipedia search window. I'd also like to put in a plug for a sister project of Wikipedia is Wiki Books, and Gary Wigan's famous resource on chemical information is now in a Wiki book source, which is listed there. I think Wikipedia is a useful source of curated information, and it's fairly reliable. We will be able to improve things further as we extend the validation. I would say if you don't find what you're looking for on the main page, don't forget to click on that data page. A lot of people do. And remember, Wikipedia is written by people like you. So we need your help in both writing and validating. So thank you very much. And I apologize for all the technical errors, which began at 11 a.m. precisely.